In this video we will learn a useful technique of expressing central moments in terms of raw moments. Now, why are we learning this formula, learning this technique? It turns out that when dealing with moments, it is so much easier to operate in terms of raw moments than it is in terms of central moments. So that's the rationale for actually learning this technique. Now, this formula may look complex at first, but there is nothing complex in it. All you need to remember that on the left side you've got a central moment, and on the right side you've got two raw moments. Okay, and you can recognize a raw moment because there is a prime sign here. The only exception to this is the mu, okay, the mean. The mean, unfortunately, is the only raw moment in the family of raw moments which doesn't have a prime sign. So if you see this without this mu letter, without anything, then it stands for mean, which is essentially the same thing as that thing here. Is the first raw moment, but it's usually written as a mu without anything. Okay, so let's do a few examples. So we are asked here to calculate zeroth central moment. So we know that n equals 0 and j will be 0 as well, okay? Because how many integers are there from 0 to n? Well, if n is 0 and j starts with 0, then there's going to be just one term, so one term here, yeah? So all you have to do is just replace n with 0 here, here, and here, and obviously replace j with the value of the integer it's taking. Because we have only one value for j, then it's going to be 0 here, 0 here, 0 here, and 0 here. And by doing so, you will get something like this, okay, which turns out that this binomial coefficient evaluates to this here, which is 1. Now, how about minus 1 to 0? Okay, this term here. Well, minus 1 to 0, anything to 0 to the power of 0 is just 1. How about the first the zeroth moment, the zeroth raw moment? The zeroth raw moment, if you remember from the definition of expectation, is just e of x to the power of 0, okay, which is the same as e of expectation of 1. And expectation of a constant is just a constant, so this is going to be 1. And now this term here, the last term, which is mu, i.e. mean, raised to the power of 0. Well, anything raised to the power of 0 is just 1. It turns out that the zeroth central moment is 1. Okay, how about first central moment? Well, when we are trying to express central moment in terms of raw moments, we know that n equals 1, and we know that j will be either 0 or 1. Okay, so we just have to sum two terms which are different in that each time we increase j by 1 until we reach the nth term. Yeah, so you can pause here and follow the expansion, and it's a very basic calculation. I won't be dwelling into it too much. Instead, I will concentrate on a slightly tougher example, i.e. calculating a second central moment, which we've got here. Calculating second central moment is easy. We have to set n equals 2, and we know that j will be equal to either 0, 1, or 2, okay, because we have to sum all the terms from j equals 0 to n, okay, so there'll be 3 integers, 3 terms. So let's expand this expression, and I'll proceed as follows. For j equals 0, I've got 2 choose 0 times minus 1 2 minus 0 times mu prime 0 times mu 2 minus 0. Okay, so each time when I see j, I just replace it with 0. Now, for j equals 1, we have 2 choose 1 times 1 minus 2 minus 1 times mu prime 1 times mu 2 minus 1. Okay, and then the third one for j equals 2, we've got 2 choose 2 times minus 1, 2 minus 2 times mu prime 2 times mu 2 minus 2. And now I will erase these j's here on the side to leave myself more space. So I will evaluate each of these terms separately. 2 choose 0 happens to be 1. Minus 1 to the power of 2 is 1. The zeroth raw moment is 1. Why is the zeroth raw moment 1? Well, it's because applying the definition of a moment, which is just an expectation of a random variable raised to the power, okay, this is the same as expectation of 1, and this is the same as 1. Okay, so that's why it's 1. Now here I've got mu to the power of 2 minus 0, so the whole term evaluates to mu squared. How about this term here? 2 choose 1 happens to be 2. Minus 1 to the power of 1 is minus 1. Now the first raw moment is just mu, okay? And then mu to the power of 2 minus 1 is just mu. So it happens we've got 2 minus 1 is minus 2, mu times mu is mu squared, so we end up with 2 mu squared. Okay, now the third term here, this happens to be 1, this happens to be 1, because minus 1 to the power of 0 is 1. Here times mu 2 prime, which is our second raw moment, times mu to the power of 0, which is 1. So from this expression we get mu prime 2. And now, summing these terms all together, we get mu squared minus 2 mu squared plus mu prime 2, which is the same as mu prime 2 minus mu squared. Okay, and I'm sure you have seen an alternative notation of this, which is just the expectation of x squared minus e of x squared. Okay, so we have completed our exercise. If you want to, you can go ahead and have a go at the expressing third and fourth central moments in terms of raw moments. But whatever you do, please bear in mind that this is what you should be getting as a result. Okay, so we have done this second central moment in detail. We have also done the zeroth central moment, and you can go ahead and try to express the fourth and the third central moment in terms of raw moments, and here are the answers as an indication of what you should be getting as a result. Thank you.